Hello, pre-algebra. Glad, actually, sorry I can't be with you today. Glad, though, that you did find the lesson, that you're able to get tuned in to what we're doing today. So today we are going to talk about proportional and non-proportional relationships. So if you remember back to the little activity we did on Monday, um, if you are a red day, it would have been Tuesday if you're a white day. So um, we did the activity with the ant and the ladybug. And we saw some things about that graph, and we compared the graph to the little tick mark diagrams and all that. And we talked about some ordered pairs, and we talked about how the lines fit on the graph, and we wrote some equations, all those things. So in those examples, all of those examples that we worked with were proportional relationships, and we know that because at the very beginning of that worksheet, it told us that the bugs traveled at a constant speed, so they were at a constant rate. So we're going to see how to identify that today, and we want to understand if there is not a constant rate, that they're non-proportional relationships. They could still be a line on a graph. There's just going to be some differences about the way non-proportional and proportional relationships look on the graph and the way they relate to one another and those kind of things. So today we're going to learn how to, or hopefully this is a refresher, because we did this in math too. We talked about proportional and non-proportional relationships, and we wrote some of these equations and things like that. So hopefully as we go through this stuff today, it will tickle some memories. It'll ring a bell for you to be able to remember how to do this stuff. So let's jump right in and let's look at some displays of data here. Determine whether the cost of coffee is proportional to the number of pounds. And so a couple of things about proportional relationships and non-proportional relationships. First of all, rule number one, as you set up proportions, rule number one, and I will ask you about rule number one. Rule number one, when setting up your proportions, money goes on top. Okay? If you have the opportunity to place money on the top of the ratio, that is where it needs to go. We could still work with it if it's on the bottom. We could still show some proportions and do some things with it, but I promise this will make life easier, especially as we get into graphing things. So rule number one, money goes on top. So as I set up some proportions here, or rather some ratios to determine if it's proportional, all I got to do is take the data points that go together. 1 pound of coffee costs $3. So I would set that up as a ratio, 3/1. And that doesn't simplify. That just stays right where it is. There's nothing I can do with that. So it's good to go. Then I would take the next one and I would do this, 6/2. So 6/2. And 6/2 can simplify. It simplifies to 3/1. All right, then I would take the next one, and I want money to go on top always. So this one I'm going to do this exact same thing and make it 9/3. And that one will simplify. 9/3 simplifies to 3/1. Okay, and then this one, 12/4 is what we would do here. Money on top, 12/4. And when I simplify that, guess what? It's the same thing, 3/1. And so notice that all four of those rates simplify to the exact same thing. And since they simplify to the same rate, we have a constant rate, and that means it is proportional. Okay, so if you have a table of data, all you have to do is set up some ratios, simplify them to see if they simplify to the same thing. If they do, if they all simplify to the same thing, you have a proportion. If any one of these is different, if any one of these had been different, then we could not claim it's a proportional relationship. Okay, so let's move on and look at a couple more examples. So the number of miles is proportional to the number of hours. Okay, are you ready for rule number two? Rule number one was money goes on top. Rule number two, time goes on bottom of your relationship. Okay, any measure of time, whether it's hours, days, weeks, months, years, seconds, minutes, whatever it is, any measure of time goes on bottom. And again, we could work with it, but this will make life easier once we get to graphing things. And that'll show up maybe here in a little bit when we get to our equations. Okay, so I want to set these time measurements on bottom. So distance on top, 50/1. That doesn't simplify. I can't do anything with that. And so I take the next one here, 70/2. 70 over 2. 70 over 2 will simplify. I have the calculator here. Let's use it. 70 divided by 2 equals 35. So 70 over 2 simplifies to 35 over 1. At this point, I've already shown that this is not a proportional relationship. So this is non-proportional. Non-proportional. Okay, so it's non-proportional because I have one that simplifies to 50 miles per hour, and I have one that simplifies to 35 miles per hour. I don't even have to check these. It doesn't matter what this one is. Doesn't matter what this one is, because I already have two that don't match, so I don't have to worry about those, okay? All right, now let's look at a third example. Table below describes the rate of growth of a Georgia pine tree. Determine if the relationship is proportional. Okay, so we have a measure of time here, the age in years, so that needs to go on bottom. They kind of set it up nice for us this way on this one. So 47.3 over 11. This line just means divide. That's all I have to do. 47.3 divided by 11 equals 4.3. Okay. Now all I have to do is look and see if the other ones equal 4.3. So 64.5 over 15. 64.5 divided by 15. 4.3. We're halfway there. Okay. So 73.1 divided by 17. 73.1 divided by 17 equals, look at that, 4.3. So far, we have a proportional relationship because we've shown that all three of those are equal. Now we've just got to check the last one. 94.3 divided by 23. And that is 4.1. All right. So, because this one is different, that makes everything else non-proportional. Doesn't matter that these three are the same. What matters is this one is different. And because that one's different, the entire relationship is non-proportional. Okay? So don't try to take shortcuts with this. If you have to show all of the data points are proportional, sometimes it takes doing some math on every step. You can't just do one or two and see. All right, sometimes you have tables of data like this to determine if things are proportional. Other times you have a graph. And a graph, hopefully you remember again, back to Math 2. I know we talked about this because I remember teaching it. Graphs of proportional relationships will always pass through the origin. We don't very often get to use this word in math because always means always. I only have to prove one example where this doesn't work and then always goes away. But this is true. Graphs of proportional relationships will always pass through the origin. So this line is a proportional line because it passes through the origin. Okay. Now sometimes they'll get tricky with us on graphs and they might give us, a graph that just has a line up here and we have to figure out if it would go through the origin or not. But that comes later on. So for now, any graphs that you see will either go through the origin or they won't. If they go through the origin, proportional. If they don't go through the origin, non-proportional. So look at these two graphs, A and B. Which graph represents a proportional relationship? Well, it's pretty obvious. There's only one that goes through the origin. This one goes through the origin. This line does not go through the origin. So this one is proportional. This one is non-proportional. That's all it means. Okay, proportional, non-proportional. Let's look at another vocabulary term. I know we talked about this one as well back in Math 2. If a relationship is a proportion, then we can determine the constant of proportionality. And there's a special letter that goes with constant of proportionality. I don't know why, but it's the letter K. And I remember talking about that last year as well. So the letter K is the letter that stands for constant of proportionality. We already know that this is a proportional relationship because we looked at this one earlier. So I know based on what we did just a few minutes ago, that this one is proportional. Now all I need to do is find the constant of proportionality. Well, there's two equations that we use. Here's the first one. K equals y over x. The constant of proportionality equals the y value divided by the x value. And this is why time needs to go on top. Because when we make a graph, you think about what a graph looks like. It's got the x-axis and the y-axis. Rule number 1 says money goes on top. Money is always going to be over here on this axis. Rule number 2 said time goes on bottom. Time is always going to be over here on this axis. Okay? That's just the way we graph things. It's the way it makes the most sense. It's the way it looks the best. It is the most easy to read, those kind of things. So K equals y over x is our equation. I know what the y value is. The y value is the money. It has to go on top. And the x value then would be, in this case, the pounds of coffee. So all I have to do is take any one of those. K equals, let's just take this one. Doesn't matter. 6 is the money, 2 is the pounds, and K equals 3 over 1 is what we said earlier to show the ratio, but it's okay to simplify that to 3. So K equals 3. That's our constant of proportionality. That's the thing that doesn't change anywhere in this problem. If we want to buy 1 pound or 10 pounds or 50 pounds or 2.5 pounds, that can change. The total cost will change based on how many pounds we want to buy. But the thing that never changes, the constant, is how much per pound we pay. So 3 never changes. That's why it's called a constant. Okay? The other equation that we will use is this. Y equals K times X. So two equations, they both use the same 3 letters, K, Y, and X. K, Y, and X. We just put them in a little different order. This is to find the constant of proportionality, K equals Y over X, and this is to use the constant of proportionality. If we know what the constant of proportionality is, this is the equation we use. By the way, this is the one from the ants and the ladybug the other day. We were using that equation, distance equals rate times time. And it's the same equation. We just changed the letters because the D, R, and T all mean something. This is kind of a generic equation that we could use for any proportional relationship. This is a specific formula that we use just for distance. Okay? And so it's the same equation, though. On the other one, we were finding the rate, but it was still the constant of proportionality. K, in this case, would be 3. So if I wanted to know how much, say, 10 pounds of coffee would cost, this is the X value, this is the Y value. Whoops, hit a button. There we go. This is the Y value. What in the world? Okay, this is the Y value, this is the X value. So Y, if I wanted to buy 10 pounds of coffee, I'd put a 10 here for the pounds. That's my Y value. Man, I'm so sorry. I wish I could rewind, but I can't rewind. I got flustered when my pen quit working there for a second. Back up for a second. This is the Y value because it goes on top. This is the X value. Okay, let me do that again. So if we wanted to buy 10 pounds of coffee, 10 would go here for the X, and the Y, we don't know what the Y is. Okay, but we can figure it out real easy here. All we would do is Y equals, I know the constant of proportionality is 3. I know that I want to buy 10 pounds of coffee. All I'd have to do is 3 times 10. So 30 equals Y. So the cost would be $30. All right, sorry about that little mix up there. I hate making mistakes just because I know it confuses you guys sometimes when I do that. All right, let's look at a couple of examples. So remember our 2 rules. Rule number 1, money goes on top. Rule number 2, time goes on bottom. Remember those 2 equations we just did. The equation was K equals Y over X. We're going to use that one first to find our constant of proportionality. And then we'll use the equation Y equals KX to solve for the last part of the problem. Okay, so Cost of 2.5 pounds of hamburger is $7.20. Here's my equation. My constant of proportionality will equal the money on top divided by the number of pounds on bottom. And you guys have calculators on your Chromebooks, or if you have a calculator to use, that's fine on this kind of stuff. But 7.2 divided by 2.5 equals 288. So that means 1 pound of hamburger costs $2.88. It's $2.88 a pound. Okay? How much will 4 pounds cost? Well, now we come over here and use this equation. How much will it cost? It will be 288 times the number of pounds. 288 times 4. So 288 times 4 equals 11.52. $11.52 will be the cost of 4 pounds of hamburger. Okay? All right, let's look at another example. Okay, 13 gallons of gas, 41 is 41.21. So again, I'm going to find my K value. K is my Y value over the X value. Rule number 1, money goes on top. So 41.21 goes on top. K equals 41.21 over 13. That is $3.17 a gallon. So K equals 3.17. Gas is not nearly that expensive anymore. This is an old problem. Okay, so now I use my other equation. My other equation just is very similar to the first one. Y equals K times X. And so I want to know, how much does 18.5 gallons of gas cost? Well, 18.5 gallons, remember that was our X value. That's the gallons went on bottom. So X is 18.5. So I can do Y equals the rate, 3.17, times the gallons, 18.5. So 3.17 times 18.5 equals $58.64.5, but we know we don't pay half cents, so we're going to round that up to 65. So 58.65. All right, this one has an additional question here. I'll switch colors for this one so we can keep them separate. All right, so we still know what the K value is. K doesn't change, but this time how much gas can be purchased for $95.10? So I know I have $95.10 to spend on gas. How many gallons can I get? Well, this time we're using this value, the money, and we know that money is Y. The money goes on top, right? So that means money is Y. And so when we put it into this equation, $95.10 equals my K value, which is 3.17, times X. I don't know how many gallons I'm going to get, and X is the gallons. So here all you have to do is divide. Divide by 3.17. Oops, 3.17. I missed a letter there, or a number. 3.17. And 95.1 divided by 3.17 equals 30. Okay, so 30 equals X. And that would be 30 gallons of gas, right? So we can get 30 gallons of gas for $95.10. All right, so we can use that this equation to figure out either the Y or the X value if we have the constant of proportionality. So don't be tripped up by that. Don't always just plug your number into this variable and think all you have to do is multiply. Sometimes you have to plug it in for Y and then divide, okay? All right, last one. Bob drove to see his grandmother and maintain a constant speed throughout his trip. Bob drove 234.5 miles in 3.5 hours. At that rate, how long will it take Bob to drive 415.4 miles? So K equals Y over X. This time I don't have money, so I don't know what goes on top, but I do have time, 3.5 hours. And I know rule number 2, time goes on bottom. So K equals 234.5 over the time, which is 3.5. 234.5 divided by 3.5 equals 67. So my K value is 67. That means Bob is traveling at a constant speed of 67 miles per hour. So now I use my other equation, y equals kx. How long will it take Bob to drive 415 miles? Think about where the miles went on this equation. The miles went on top, so that means it's the y value. Miles is y, that means it goes in here. Okay, 415.4 equals 67 times x. X is my hours. I don't know how many hours it's going to take to drive that far. Okay, so all I have to do now is divide by 67. 415.4 divided by 67 equals 6.2. So 6.2 hours to drive that far. So 6.2 hours will get me all the way to Grandma's house, I guess. Okay, so hopefully that rings a bell. Hopefully you remember some of those things from last year in Math 2. We did all of this constant proportionality stuff. We talked about the graphs. We talked about the tables and how to figure out if things are proportional or not. That should have all been reviewed, but at this point, there's a Desmos activity for you to spend a little time on, and then there is an assignment that will be due at your next class period. So if you're red day, it'll be due Friday. If you're white day, it'll be due Monday. So be sure to grab one of those assignments before you leave the room today. Thanks, guys. Whoops, how do I get out of here? There we go.